Hello. This video is going to discuss how to solve basic radical equations. And also we're going to check for any extraneous solutions. Okay, so we're going to start with some basics. Whenever we solve a radical equation or any equation in that matter, we always are looking to isolate the variable. We're looking to get the variable all by itself. So we kind of use the reverse order of operations. So if you take a look at number one, I have 2 times the radical of x plus 7 equals 15. My goal here is to try to get this radical all by itself, and then we're going to get rid of that radical. So I'm going to subtract 7 from both sides, which gives me a 2 square root of x equals 8. I'm then going to, I'm going to then divide by that 2, which gives me the square root of x is equal to 4. And now the inverse operation of a square root is the exponent of 2. So to finish this off, what I'm going to do is I'm going to take both sides and I'm going to square them. Now, when you square a square root, you're left with just the argument and the inside. So we then just have 4 squared, which is the value of 16. Now, as soon as you're done solving any radical equation, we always have to check for something called extraneous solutions. So I'm going to take that x value, I'm going to plug it back in. So I have 2 times the square root of, instead of x, I'm going to use my answer. Square root of 16 plus 7 equals 15. And then I want to make sure that the left-hand side of my equation is, in fact, equal to 15. So I'm going to say 2 times the square root of 16 is 4 plus 7 equals 15. I'm doing one step at a time. 2 times 4 is 8 plus 7 equals 15, and 8 plus 7 is 15. So that checks off. I know that x equals 16 is in fact the solution to that equation. So I have a series of 6 problems here. They're all a little different. Some of them have some different radicals, but we're going to go to number 2. All right, feel free to pause if you want to try to do any of these on your own. So I'll give you a minute to do that. Okay, and I'm going to go ahead and solve. So what I'm going to do is I'm going to try to isolate the radical. So I have 3 times the square root of x minus 4. So the problem is I can't get anything to the inside of the radical, so I have to get rid of the 3. So I'm going to divide both sides by 3, and I get the square root of x minus 4 equals, and 21 divided by 3 is 7. Now I want to get rid of that radical so that way, I want to get rid of that radical so that way I can isolate the value of x. So what I'm going to do is I'm going to take this radical and I'm going to square both sides. So I get an x minus 4 equals 49, because 7 squared is 49. And I'm going to, last but not least, add the 4 over, which gives me x to equal a value of 53. Okay, but just like the last problem, we're going to check our answer. So I'm going to take that number and substitute it in for x. So I have 3 times the square root of 53 minus 4 equals 21. So I want to see, does that radical actually equal 21? So I'm going to say 3 times the square root, 53 minus 4, I believe is 49, equals 21. And 3 times the square root of 49 is just a 7. And 3 times 7 is 21. So look at that. That works. I know 53 happens to be the solution. Okay. Let's go to number 3. If you take a look, now this is slightly different. Instead of a square root, you can see that my radical is now a cube root, right? So I want to isolate this cube root, so I'm going to leave it the same for right now. So I'm going to say 2x minus 1 minus 4 equals negative 1, but I want to add the 4 over to the other side. So get rid of everything except for the radical. Now you can't touch anything inside the radical, but everything on the outside we are going to remove. So I have the cube root of 2x minus 1 is equal to now 3. And I don't know if you guys realize this, but when we had a square root, we squared both sides. Well, if I have a cube root, I'm going to cube both sides. That's the inverse operation. So we always just use inverse operations. So I get a 2x minus 1 equals now 3 to the third power. So that's 3 times 3 times 3. That is going to give me a value of 27. Now from there, I can add 1. Hang on. Let's get this working. Add 1 to both sides. So I now have a 2x equals 28. And if I divide by 2, I'm going to get x to be 14. Okay, so now let's check that value, right? So I'm going to say the cube root of 2 times 14 minus 1 minus 4 equals negative 1. So I have the cube root of 28 minus 1 minus 4 equals negative 1, which is the cube root of 27 minus 4 equals negative 1. Now I need to figure out what this cube root is equal to. But if you do this, this is 9 times 3 or 3 times 3 times 3, right? So I have a group. So this radical, the cube root of 27 is just 3. Minus 4 equals negative 1. And 3 minus 4 is a negative 1. So look at that. It works. Okay, so we can always check our answer. Now you also have a calculator, so if you just want to do the cube root of 27, you're welcome to do that, but you should all know how to simplify a radical. Okay, let's take a look at number 4. Now number 4 isn't a cube root, but it's a fourth root, so you might actually need a calculator for this one. What we're going to do is we're going to subtract the 8 from both sides. So I have a 3 times the fourth root of x equals 6. I'm going to divide the 3 to both sides, which gives me a fourth root of x is equal to 2. And just like we did before, I'm going to use the inverse operation here, which is going to be the power. Get my stylus working here. There we go. Okay. Which is going to be the power of 4. And I now have x equals 2 to the fourth power. If you were to do that in the calculator, just do 2 times 2 times 2 times 2, so 4 2s. That gives you a value of 16. Okay, so now let's check our answer. So if I say 3 times the fourth root of 16 plus 8 equals 14, I'm going to say 3. Now, the fourth root of 16, you could do this in a calculator, or you can just break it down. You could reduce the radical. This does give you the value of 2 plus 8 equals 14, which is 6 plus 8 equals 14, or 14 equals 14. Okay, that works. Always want to check our answers, okay? Now, if you take a look at the next two problems I have, they're slightly different. They're actually, I think, my opinion, I think they're a little simpler, but we can't really move anything to the other side. Everything's stuck in these radicals. But if you notice, both sides of my equation have the same radical. So what I'm going to do, okay, is I'm going to start with the inverse operation, right? So let's say I want to get rid of the radical on the left side. I'm going to square both sides. Well, what I do to one side, I have to do to the other. So if I square both sides, I'm going to be left with a 2x minus 6. And if you notice, it cancels out the radical on the right-hand side as well. So now I just have a 4x minus 14. So if you have two of the same radical, or same type of radical, you know the insides have to be the same. Ultimately, I know that 2x minus 6 has to equal 4x minus 14. Now we can just solve, right? So I'm going to get all my variables to one side. So I get a negative 6 equals 2x minus 14. Add the 14 over. So I get an 8 equals 2x. And if you divide the 2, you would get x to be 4. So again, just like all the other problems, we need to check our answers. So I'm going to say 2, and instead of x, we're going to put in a 4 minus 6 equals the square root of 4 times 4 minus 14. 2 times 4 is 8 minus 6. 4 times 4 is 16 minus 14. 8 minus 6, I have the square root of 2. And on the right side, I have also the square root of 2. I know that the left and right-hand side of my equations are now balanced. They are the same. I know that the answer has to be 4. Okay, last problem, solving basic radical equations. So this one, instead of square roots, I have cube roots, but ultimately, I'm going to do them the same. If you have the same radical on both sides, I know I'm just going to raise each side to the third power. That gives me x plus 15. That has to equal a 5x plus 3. And now we just need to get all the variables to one side. So I'm going to go ahead and subtract x, which gives me a 15 equals 4x plus 3. I'm then going to subtract the 3, which gives me a 12 equals 4x. And if you divide by the 4, 12 divided by 4 is 3, right? So let's finish this off. Let's check our answer. I have the cube root of 3. So my variable was had a value of 3 plus 15 equals the cube root of 5 times 3 plus 3. So let's see if we get the same thing here. I get the cube root of 18 is got to be equal to the cube root of 5 times 3 is 15 plus 3. Or we know the right-hand side, 15 plus 3 is 18. Notice the left and right-hand side of my equation are balanced. So again, solving basic radical equations. I want you to isolate the radical if you can, and then use the inverse of that radical to solve it. And then you'll be able to solve basic radical equations. Be sure to check for extraneous solutions. This is going to end up being a 2-part video. The second part will come later. But in the next video, we're going to have more extraneous solutions to watch out for. So thank you.